Hello, everyone. So, in the previous chapter, chapter 14, we have discussed congruences, more on congruences. There we have talked about Fermat's theorem, Fermat's test, Miller's test, and other ways of finding the large prime numbers and then checking whether they are prime or not. Okay. So now we are doing a chapter which needed all of that information which we have covered in last chapters. And this chapter is called Secret Codes. So, since the time immemorial, people have found it necessary to send information to others in a secret way, so that even if a message is intercepted by a third party, it can be read only by the intended recipient. So this is usually achieved by converting the messages into a into a string of numbers or letters according to some rule that only the sender and recipient know. The process of converting the message into such a string is called encoding, and the process by which the recipient converts the received string back to the original message is called decoding. So, for example, one of the simplest imaginable encoding rule would be to substitute substitute 0, 1 for an A, 0, 2 for a B, 0, 3 for a C, and so on, until we get to 26 for a Z. Okay. Then the message. Let's say let's write it with a different one. So you can say MALLBRAIN is the culprit. Okay. Now, gets encoded is the string of numbers. The message this gets encoded is the string of numbers. Which numbers? The numbers would be 19, 13, 01, 12, 12, 02, 18, 01, 09, 19, 20, 08, 05 03 21 12 16 18 09 20. Let's say this is equation 15.1. Now, if you make the two pairs, you will understand that what letters we are talking about. So this is, let's make two pairs. Right? So you can say this is S, M, A, L, L, B, R, A, I, N, I, okay, I, S, let's say T, H, E, C, U, L, P, R, I, T. Now, small brain is the culprit, but BRAIN, IS, I hope I have not missed something. So this is how you can do that. Just compare them. However, anyone with a modicum of intelligence would be able to break this code in a matter of minutes if they know that we are taking 01, 02, 03 for the alphabets. So in a view of millions of internet transactions, sensitive business and government communications, and so on, they take place every day. Some rather more sophisticated ideas are required to ensure the secure transfer of information in today's world. The codes now in use for such purposes, so-called RSA codes. So we use now the RSA codes. These are based on some theory of these are based on some theory of primes, prime numbers, and congruence. Congruence. Now we can explain these codes in few pages when we will explain them in next pages. So before going into the theory, let me explain the crucial fact that gives these codes their security. Any form of security is based on things that attackers are unable to do. In this case, information is being transmitted electronically by a computer, so security needs to be based on something that computers can't do quickly. So let's say what computers can't do quickly? And if the answer to this is, if you take two primes to reasonably prime numbers, say 1301 and 2089, you can find their product. So their product of then their product 1301 multiply 2089 is 271,177,7789. This is their product using a calculator in few seconds. Now, if you were given the product 271,7789 and asked to find its prime factors, it would take you and your calculator much longer. It would take you and calculator much longer. Okay. The same kind of observation applies if we bring very powerful computers into play. So if you doubt this, try using a calculator and try to find the factors. Now take two prime numbers. Take two very large primes. Primes P and Q. Say with 200 digits each. And we have outlined that how we can find such primes in the chapter 14 and calculate their product. Now keep P and Q secret, but tell the most powerful computer in the world today the value of PQ. But tell the most powerful computer in the world today. Right? In the world today, the value of PQ, the value of their product. Then, however, cleverly, that computer is programmed then, however, cleverly, that computer is programmed at least with ideas available today. It will probably take at least several centuries. Probably take at least several centuries for it to find out what P and Q are. So computers find factorization of large numbers difficult. Let's note that. Computers find factorization of large numbers difficult. Perfect. So here we will end this part of the introduction, and then we will talk about the RSA codes, encoding, and then decoding. Okay.